Welcome back to the course on CAT, and in today's lesson I am doing this chapter on logarithms. A lot of people have been asking me to do this, so I'm first going through all the rules of logs in today's session, and we'll then continue that with the next session where we'll add some questions and problem solving on logs so that you understand this thing. Logs as a chapter is not very important. It's important in the context that you get a couple of questions from, and CAT 18 had 4 questions from log in each slot, but off and on kabhi rehta hai, kabhi nahi rehta hai. So you have to do this chapter. You can't leave this chapter, because as happened in CAT 2018, a lot of people had left this chapter, chhod diya tha, and when you leave a chapter in which 4 questions come and you are doing the paper out of 30 questions, you suddenly have, if you're targeting around 22 attempts out of 34, you are now doing 22 attempts out of 30, which means that you were earlier doing 2 out of every 3 questions. Now you have to do 3 out of every 4 questions, which means that the elbow room that you have to leave questions goes down. And as they did in as the wickedness that they did with the CAT 2018 paper was that the logs questions were very simple, LOD 1 level, and the arithmetic, which everybody had studied quite a bit, they raised the level of difficulty. The 13-14 questions on arithmetic, out of which 4 or 5 are almost not solvable by someone who had not done 500, 700, 800 questions on each chapter. You would not be able to solve those questions. So it became a very tight squeeze then for people who are trying to attempt 22 questions out of 34, because 4 questions went from logs because you not studied it. 4-5 questions from arithmetic, the area which you had studied, were not doable. So suddenly you're solving the paper out of 23-24 questions, and every question then you had to do if you wanted to get to 22, which is obviously not possible, because kahin na kahin tumhara or failures hoga hi in some chapter or the other. So that's why you should not leave this chapter, and you should do this chapter well. So logs mein jab hum log jate hain, so there are 7-8 things we need to look at. The first is the definition of logs, and I always remember the definition of logs through a simple strategy. I remember this, that log 100 to the base 10 is 2. This is something that you need to remember. Or log 10 to the base 10 is 1, log 100 to the base 10 is 2, log 1000 to the base 10 is 3, and so on. And we'll see the formula, the relationship that gives us that a little bit later. But log 10, 100 to the base 10 is 2, and the only way you can connect these 3 numbers in another form, in an equality form, is if you use 10 square is equal to 100. So this is where the definition of logs come in, and you can remember it this way. And from here you can derive that if a raised to b is equal to c, then the definition of log basically is log c to the base a is equal to b. A is 10 here, b is 2 here, and c is 100 here. So log 100 to the base 10 is equal to 2. So this is the definition of logs. If a raised to b is equal to c, then log c to the base a is equal to b. This is the definition of logs, and this definition is used in both directions. This direction also and this direction also. They're used in both the directions. You can go from this to that, a normal exponential relationship to a log relationship, and from a log relationship you should be able to come back to an exponential relationship. And as I said, you remember this or memorize this through this structure. This you can't forget. इससे तुम उसको derive कर सकते हो कभी भी. ठीक है, I'm just repeating this. यहाँ पे a raised to b is equal to c के फॉर्म में अगर इसको देखोगे, if you look at this equation, a raised to b is equal to c, so a is 10, b is 2, and c is 100. And if you take this there, 100 is c, and a is 10, and b is 2. So log c to the base a is equal to b, which also means a raised to b is equal to c. So you have to remember it vice versa also. If you get this, you should be able to go there. A raised to b is equal to c. Right? So this is the definition of logs. This is the first thing. Now then there are certain rules that apply to logs, which you can apply to logs. And logs, there are basically around 7, apart from the definition, there are 7-8 more things that you need to remember. And the good part about logs is that all the questions, no matter what question you will get in logs, no matter how difficult the question is, ये 7-8 ही rule है जिसमें which is chapter में, which you have to use and you have to know. And some of these rules are the same base rules, and the other rules are base change rules. So we are talking about the same base rules in logs first, and the first one is the usage of something which I have written there as log A plus log B. But when I say log A plus log B, they should be the same base, let's say C. If log A plus log B to the same base C is there, so then this can be written as log AB to the base C. This is the first base change rule. This is the first base change rule. If log A to the base C plus log B to the same base C is there, then you can write log AB to the base C. And this rule is used going from the left side to the right as well as from the right to the left. What do I mean by that? What I mean by that is, suppose you have a situation where you are where you have something like log 150 to the base 10. तो इसको तुम, if you want, you can split this 150 into its factors. Now this is the going from right to the left situation. You know log AB, and now you want to break it into log A plus log B. So for example, if you can think of this as 10 into 15, 150 as 10 into 15, one of the moves you can do in this question is you can write this as log to the base 10 10 plus log to the base 10 15. So this is something that you can do in this situation, and you will see log A to the base A, log 10 to the base 10 is 1. So you can write this as 1 plus log 15. And you can further break down log 15 as 5 into 3 if you want to, and you can further simplify this if required based on the situation in the question. And what do you do? Should you take 10 into 15? Should you take 25 into 6? Should you take whatever? I think you're not having yeah, you got a 30 into 5. Should you take a 30 into 5 there? What should you do? Which one should you use? Or should you use a 10 into 3 into 5? That trigger you will get from the question and from the options itself. The question and the options will give you enough clues if you learn how to read them, कि किस direction में जाना है मेरे को इसको लेके. So you don't need to bother much about it. You should just know the application of this. And the reverse side application of this is, if I have a log 30 plus log 20, let's say both to the base 10, then I can convert this to log 600. See, the main underlying condition where you are allowed to do this is that the base should be same. It could be base 10, it could be base x, it could be base 5, it could be base 2, but you can only do this on the same base log. So where it does not apply, if I have a log 2 to the base log 30 to the base 2 plus log 20 to the base 5, this, no matter how much I want to, I cannot write this as log 600. I cannot do this because the base is not same. So you have to remember this, that this rule applies only when the base is same for both the logs, right? And of course this also applies to log A plus B plus C, log A plus log B plus log C. So if I have a log 5 plus log 20 plus log 50, suppose, so I can, and the base is same, and when I don't write a base in a log situation, then the underlying base value, if it's not written, is assumed to be as 10. So it's called the natural logarithm when you use the base, when you don't write the base in a log, the assumption is that the base is 10. So if you want, you can write this as log 5000 to the same base, whether the base is 10. If I'm not writing anything, it means the base is 10. अगर मैं b लिख दूँ इस पे, log 5 to the base b, log 20 to the base b, and log 50 to the base b, then I can write this as log 5000 to the base b, and vice versa. I can convert this back to that also if required, right? And of course, as I said, what you convert it back to, you should know the rule. What you convert back to, the question will tell you itself. The question or its options will help you understand that. The next one, the next clue here is, or the next base change rule is the one in which you use the subtraction. That means if you are doing, again this is the same base rule. If you have a log A minus log B, if you have a log A minus log B, you can write this as log A by B. Again, the base should be same in both of them. If this is the base C, this should also be the base C. So log A minus log B can be replaced by log A by B to the base C. How is this used? In what conditions is this used? Suppose I have a log 200 minus log 20. I can write this as log 10. And if the base is 10, log 10 to the base 10 is 1. So I can convert this into 1 directly. So this is allowed. Sometimes you also use this to move from the right to the left. For example, sometimes you might want to use this to move from the right to the left. So for example, if you have a let's say the right hand side is log 250 to some base B. So you might want to visualize that 250 as A by B if you want to come back from that side to this side. You might want to visualize the 250 as A by B. And when you do that visualization, you might, depending on the situation, you have options. You can visualize 250 as 500 by 2, or if the base is 10, you might want to visualize it as 1000 by 4. So if I visualize this as 1000 by 4, if I visualize 250 as 1000 by 4, I can come back to this side, writing this as log 1000 minus log 4. And if the base is B, then this will remain as it is. But if the base is 10, then log 1000 to the base 10 is 3. So I can write this as 3 minus log 4. So this is a simplification that happens. So these are standard moves in logarithms. So when you have a log which is a composite log, you have to try to think in both directions. Can I build this based on, suppose I have a log 4 in my options in this. So then I will try to think about this, कि 1000 by 4 कर सकते हैं इसको. If I have a log 25 for example, then I might want to use 25 into 10 here. In my options, if I got a log 25, then I might want to use 25 into 10 there. So when you have this argument on this side, when you see that this is a skill that you'll need to develop. So when you see a log, you see an expression like this, as I said, you see a log 250, then your mind has to go in both directions. What should I do? Should I look at it as multiplication of two numbers, or should I look at it as division of two numbers? So what suits the current situation? What suits the current options? As I said, in this case, if my options have a log 4 inside them, so I might want to think about this as 1000 by 4. But if my options have a log 25 in them, then I might want to think about this as 25 into 10. So this is the finesse you'll develop as you keep solving these logs questions. So this is the second rule. This is the base change rule, where you the same base rule where you're using log A minus log B. The third rule, ये दोनों rule के बाद you have some properties of logs. I think I have missed out a couple of slides here, so I'll put it here. The third one, which you should know, this is the third rule, and the first, the original one, of course, was the definition of log, and we've done two same base rules, and this is also a same base rule only because when you use log a raised to b to the base c, a raised to b to the base c, this can be written as b log a to the base c. right? So if in this case you need to be a little bit careful about this. When you write a log, it has got a value or the argument of the logarithm, and you've got a base. So this a raised to b is inside that value. Please don't misinterpret this as log a raised to b. Log a whole raised to b means log a into log a into log a b times, right? So you cannot write this. So if you have a trigger like this, be a little bit careful about this. This is a mistake starters make. If you have a situation like this, log 2 cube to the base 10, or I'm not writing a base, it means a base 10, I can write this as 3 log 2. But if it is log 2 whole cube, then this basically, no matter how much you want to write it as this, you can't, because it means log 2 into log 2 into log 2. This is what this means. So you cannot use this if you're using if you have that power after the brackets. That means the whole logarithm itself is raised to a power. So remember that. So this is the third one, and so the third one was essentially log this one. Just note this: log a raised to b can be written as b log a to the same base. So इसमें you are not changing the base of the log in this question. In this situation, you are not changing the base of the logarithm. So after this, the fourth rule is basically, and it's not a rule, it's a property actually. The logarithm of 1 is always 0. The logarithm of 1 is always 0. That means if I am taking a log of 1, and please note, this can be any base. This can be any base x. Log 1 to the base x is always 0. 1 to the base 2, 1 to the base 5, 1 to the base 10, 1 to the base 20, 1 to the base 100 is always 0. The reason is this logic comes from the definition of logs, because when you write log a to the base b in the definition of logs is equal to c, this basically means b raised to c is equal to a. So if I don't use a 0 here, I have a contradiction that I cannot get a value of 1 on the value of x raised to 0. So that's why you use x to the power 0. I mean log x 1 to the base x is always 0. So log 1 is always 0, just remember that, and this we will also see when we look at the graph of logs. So ये fifth point हो गया logs का, जो तुमको याद रखना है. Sixth point, you have to remember log to the same base. That means log of x to the base x is always 1. Right? Log of a to the base a is always 1. Log of 10 to the base 10 is always 1. So if you combine the power rule and this rule, that's how you get log 10 square to the base 10 is equal to 2 log 10 to the base 10, which is equal to 2 log 10 cube to the base 10, which means log 1000 to the base 10 is 3 log 10 to the base 10, which is 3. So the power rule and this combines. Similarly, log 8 to the base 2 kind of numbers. These are standard reactions that most people who know logs have. So log 8 to the base 2 can straight away be written as 3. The internal steps to get there is log 8 to the base 2 can be written as log 2 cube to the base 2, and this can be written as 3 log 2 to the base 2, and log 2 to the base 2 is 1 according to this rule, which means that the value is 3. So these kind of transformations you have available based on the indice rule. Log a raised to b is b log a, based on that rule, and based on this second rule where you have log a to the base a as 1. So this is your fifth point, which says log a to the base a is 1. So this is the fifth major point that you need to remember about this. Then there are certain base change rules. Many times when you don't have a rule, which is when you don't have a base change rule, or when you don't have this the working situation in which the bases are same, then you feel a lot constrained. You feel hugely constrained in those questions. So for those, there are 3 rules that you need to know, the 3 base change rules, the 3 rules that allow you to change bases. The first one is a constraint rule, in the sense that what it says is, if I've got an index in the base, so suppose I'm saying log x to the base a raised to b. That means the base itself is a power. So this becomes 1 by b log x to the base a. So this index in the base comes out as a multiplier, or rather a divisor to the log value, right? So example of this is, suppose I've got log 16 to the base 8. So in such situations, I can use the fact that my base here is 2 cube. So if I take out the 3 from the base, from the power of the base, this will become 1 by 3 log 16 to the base 2. And since 16 is nothing but 2 raised to 4, so this value itself is 4, because the 4 will come out. So the expression log 16 to the base 8 gives us a value of 4 by 3. So these are standard steps that you have based on the first base change rule, right? Those 5-6 points on the other side when we are on the same base, including the point about definition of logs. And this is the first base change rule that you need to know. The second base change rule, which is actually a very powerful rule in logs, and this will be applied in a lot of difficult questions, is this rule. This is the actual base change rule in logs, and what this says is that if I got log a raised to b, a to the base b, log a to the base b, then I can write this as log a to the base c upon log b to the base c, which means I'm allowed to introduce, please notice on this side there is no c, so I'm allowed to introduce a c as per my liking on the right side. The c is introduced by me in the problem solving situation, so I'm introducing c. So it allows me to introduce any new base c, provided I shifted to log a by log b to the same base c. So this is the real base change rule in this. So how is this used? Suppose for example a sample usage of this, let me show you that. Let's say you have a situation where you have a log 80 to the base 20. तो इसको simplify करने के लिए I can introduce a base 10 on the right side. So I can write this as log I can't write that 10, log 80 to the base 10 upon log 20 to the base 10. And then I can see that log 80 can be written as 10 into 8, 80 can be written as 10 into 8. So I can write this as log 10, I mean once I split 80 as 10 into 8, I can write this as log 10 plus log 8. I'm not writing the base because the base is 10 and you can get by without writing the base 10. So log 10 to the base 10 plus log 8 to the base 10, and the denominator can become, I can think of 20 as 10 into 2, and this will become log 10 plus log 2. So the final simplification of this is 1 plus log 8 upon 1 plus log 2. Or this can further be written as 1 plus 3 log 2 upon 1 plus log 2. So this is a sample utilization which sets you free, and of course you also had the option of writing 20 for example as 100 by 5, in which case you could have also shifted the denominator to log 100 minus log 5, which is 2 minus log 5. ये भी कर सकते थे इसमें. So there are so many options that you have. Which one you use will depend on, I mean this will typically be part of a simplification question. So if the option has the log 5 in the denominator, you'll go in that direction, 100 by 5. If the option has a log 2 in the denominator, you'll go in this direction. Similarly, you'll need to think about whether you want to do 80 as 10 into 8, or you want to use it as 400 by 5 or 800 by 10. What do you want to do? Depends on what's there in the numerator of this expression and where you want to take it, right? And suppose this is the correct option in a question like this. The indicator that you have to introduce a log 10 here is visible right at the start. If you're looking at options like this, the last option is log 2 to the base 10 here, log 2 to the base 10 again here, and in this original expression there is no base 10 here. So the introduction of base 10 is a natural thought that comes directly from the options of what you are trying to simplify it into. So this is your second base change rule, and इसी का corollary है, which is the third, which we can call as the third rule in base change, and that corollary is this, that instead of introducing a base c, if I got a log a to the base b, what we did was we introduced a new base c. Instead of introducing a new base c, if you introduce a base b itself, one sec, what am I doing here? Sorry, not base b. If you introduce a base a, instead of introducing a base b, you introduce a base a. So what happens? You get log a to the base a upon log b to the base a, and since log a to the base a is 1, the ultimate outcome of log a to the base b is 1 upon log b to the base a. So this is used very commonly. CAT 2018, for example, there was this question which talked about 1 upon log 10 to the base 5 1 upon log 10 to the base 5 plus 1 upon log 10 to the base 2. If you've got something like this, you can convert this to log 5. I mean log 10 to the base 1 upon log 10 to the base 5 can convert, inverted it, log 5 to the base 10, and this will become log 2 to the base 10. So if you're trying to simplify this expression gets simplified as log 5 to the base 10 plus log 2 to the base 10, and you'll then multiply it, so it will become 5 into 2, 10. 10 log 10 to the base 10 will become 1. So CAT 2018 had a question. One of the questions that was there was something like this, where there are 5 values in this, everything log 10 to some different base, 2, 3, 4, 5, 20 kind of base. All you have to do is multiply these bases and put them on a base of log 10 and get the value when you put them in the numerator. This was using the base change rule, third base change rule, which is a corollary of the second one, which allows you to write log a to the base b as 1 upon log b to the base a. This is the rule, and this is the logic that allows that to happen. You can write this as this, and this is the logic that allows that to happen. Okay, so that's about it. Couple of small things further. I mean, this is not a small thing. This is about the next thing you need to understand and know is about the standard logarithmic curve. So the standard logarithmic curve always goes in this fashion. As we know, log 1 to any base is 0. So the standard logarithmic curve will have to be here, and before this it's asymptotic to the y-axis, and here it goes faster and then keeps flattening out as it keeps going ahead. This is the logarithmic curve, and this value is always 1. Log 1 is always 0. It does not exist. A log, when we talk about definition of log, when we talked about log a to the base b, log a to the base b, the value can be negative for the logarithm, the outcome can be negative, the base can never be negative or 0, and the argument a can also not be negative or 0. A is always non-negative. So the definition of the graph of the log is always to the right of the y-axis. Does not exist to the left of the y-axis. Of course, if you put a modulus here, mod A, then you get a mirror image of that on this side. So log mod A to the base B becomes that. We've talked about what happens to graphs when you put a modulus on the argument in my basic classes of block 5. So have a look at that. So there's no reason why the logs graph will behave any differently. And then a couple of rules, couple of properties again, a couple of inequalities. If A is greater than 1, then log x1 and if log x1 to the base A is greater than log x2 to the base A, then x1 is greater than x2. This happens if A is greater than 1. So if the log is greater than log of one number is greater than log of another number, then the first number is greater than the second number if A is greater than 1. But if A is less than 1, so if you're talking about let's say a log to the base 0.5, in that situation this reverses. If log x1 is greater than log x2, then x1 will be smaller than x2. Normally if log x1 is greater than log x2, then x1 is greater than x2, because most of the time you're dealing with bases which are more than 1. But when you're dealing with base which is less than 1, in such a situation the inequality reverses. And couple of implications of this. The characteristic that means the value of common logarithms of any positive number less than 1 is negative. This we know in the graph also. If I'm talking about the value of the graph less than 1, the value is the characteristic or the value of the graph is negative. And this is an important point. If the logarithm to any base A gives the characteristics n, then we can say, I mean first 2 points here, we'll come back to the third one. The first 2 points here are basically talking about the same thing as I just mentioned through the graph. कि graph में graph of a log curve, if you are looking at a graph of a log curve, the standard graph, when the argument is more than 1, then the value of the graph of the log becomes positive. If the argument is less than 1, the value of the graph becomes or log becomes negative. At 1, the value of the log is 0, right? So that is what the first 2 points are saying. But what is the third point saying? If the logarithm to any base A gives the characteristic n, what do we mean by characteristic of a log? The characteristic of a log is not the complete value of the log. It means suppose I'm talking about, suppose I say log x to the base y is 2.312. So this 2 is called the characteristic of the log, right? This 2 is called the characteristic of the log. So if it's giving a characteristic n, then we can say that the number of integers possible is given by a raised to n minus 1 minus a raised to n. So what does it mean? So if you are let's say doing a log to the base a, log n to the base a, and you're getting a characteristic of 2 point something. So how many values can n give you? How many values can this n give you? So that answer is basically a raised to 3 minus a raised to 2. If the logarithm to any base a, I mean I think this using this n here is might be confusing to you. Let's say we talk about log m to the base a and its value is 2 point something, and I want to know how many values are possible, how many integers are possible for m कितने integer values ले सकता है. तो उसका जो आंसर है, m का number of integers value is a cube minus a square. This is the number of values, integer values that m can take. So this is used very commonly in the base 10 situation. What it means, and you can also think about it this way, that when the log curve never comes down, right? Log curve is always going up. It's always an increasing curve. So if you talk about log 100 to the base 10, it's got a characteristic of 2, and log 1000 to the base 10 has a characteristic of 3. So if I put any number here and my characteristic is still 2, then this number inside this has to be a number between 100 to 999. And that tells me that there are 900 numbers that can happen if my characteristic of log m to the base 10 is 2 point something. So that's what this condition was telling me. 10 cube minus 10 square. A cube, a raised to characteristic plus 1 minus a raised to characteristic. So here the n being used as the characteristic of the log. So a is the base. So if the base is 10 and n is 2, so 10 cube minus 10 square will be the number of values that m can take. It's not a very important thing in logs, but sometimes logarithmic inequalities में इसको use करना पड़ता है. And I'll show you some questions in which this is used in the next class. Otherwise, I think focus on the first 9-10 things, and this should be enough for you to understand the basic theory of logs, and some assisted problem solving following this, followed by your own self problem solving on this should sort this chapter for you. As I've told you at the start of the class, you don't need to go very deep in this chapter. Maybe just 50 to 100 questions, and then look through the previous year questions. You should be fine for it, right? So thank you so much, and I'll see you in the next class. Bye-bye.